a trig identity that says sine of theta is the same as saying 1 over cosecant of theta. Do you agree with that statement? Yes, because they're reciprocals. They call them fundamental identities, meaning like they're like the basic identities that you should know. So we can go through with all of these and just write them as 1 over the reciprocal. So cosine's reciprocal is secant, so we can say cosine of theta is the same as 1 over secant of theta. And tangent of theta is the same as 1 over cotangent of theta. And we could do the same for the other ones here. They're just going to be the other reciprocals. So cosecant of theta is the same as 1 over sine of theta. Secant is 1 over cosine of theta. And cotangent is 1 over tangent of theta. They call these the reciprocal identities, maybe. We'll write these out again in chapter 5. But. Also, we can write tangent and cotangent another way. What's the ratio for tangent in like unit circle? Tangent is y over x, and since y is sine and cosine is x, we can say that tangent is the same ratio as taking the sine over the cosine. Which means that cotangent, you just flip it over. Cotangent is x over y, or that would be the same as saying cosine over sine. So what's kind of cool about trig functions is you can write them all in terms of sines and cosines, because you could change them all in terms of sine and cosine if you get something else. Something else that we talk about, which I'm going to throw in today, again, we'll talk about later, there are these Pythagorean identities. There's 3 of them. One of them is if you take the sine of an angle and you square it. So here's a little notation for you. If I want to square sine, right, you might say you would write this, sine squared. But doesn't that look like the squares on the theta? So you could do this. You could say I want to square sine, but instead of having to do parentheses, what we do is we put the square up here by the sine. So we say sine squared theta. That means sine is squared, not the angle. And if you square sine and you add that to squaring cosine, that will always add up to 1. And we could do a little proof of that. If you think about the unit circle, sine is the y, cosine is the x. The hypotenuse of every triangle is 1, or the radius. So sine squared plus cosine squared has to equal the radius squared, which is 1. But it's just kind of a cool thing to know. What else is there? 1 plus tangent squared theta equals cotangent squared theta. And what are the other 2 that are left? Secant and cosecant. 1 plus secant equals cosecant, I think. Squared. I'm going to double check that one. That's always the one I'm the least confident about. After a year off of these. We're not going to use these a lot today, but I just wanted to give them to you just so that you can see 1 plus tangent square. Yeah, this is wrong. Just kidding. Hope you're using pencil. 1 plus tangent squared equals secant squared. It's all wrong, kids. 1 plus cotangent squared equals cosecant squared. Oops. There's proofs for all of these. They all have to do with triangles and a squared plus b squared equals c squared. Eventually, chapter 5, we will learn those and know them like the back of our hands. But today, I just wanted to give them to you and for a question and solve it. Okay? All right, more. The next slide. It's a nice little sentence here. Co-functions of complementary angles are equal. What does complementary me? Like on your last test, you had to find a complement and a supplement. What's complementary? They add up to 90 degrees or they add up to pi halves. So that's what complementary means. Cofunctions are angles that go together. So we haven't talked about this, but sine and cosine are cofunctions, which means if you take the sine of some angle, it will equal the cosine of its complement. What's a good example of that? 30 degrees and 60 degrees. Do you agree that the sine of 60 degrees equals the cosine of 30 degrees? Think about our 30, 60, 90 triangle. That's true for any two angles that add up for 90. So this is just like the notation of it. We could say pi halves also. But the sine of 90 degrees minus some angle will always equal the cosine of that angle. And the cosine of 90 degrees minus some angle will always equal the sine of that. People get really confused by that notation. But basically, if we go down to the bottom of this, I would just say that means the sine of 30 degrees will always equal the cosine of that complement, which is 60 degrees, and that's an easy one we can prove. But we can do it for even really ugly angles. Like the sine of 10 degrees has to be the same as the cosine of what angle? 80 degrees, because they're complementary angles, okay? This could be in terms of radians also, pi halves. Just subtract from pi halves to get those. So sine and cosine go together, and then these other ones I wrote across from each other. Tangent and cotangent are cofunctions, which means the tangent of some angle from 90 degrees will be equal to its complement in cotangent. So this is just cotangent, and this one is just tangent. Again, a really easy one to pick is like 30 and 60, or 45 and 45, because they both add up to 90. And then secant and cosecant are also cofunctions, and so their secant of 90 degrees minus theta is equal to cosecant, and cosecant of 90 degrees minus theta is equal to secant. We're going to do a problem in a minute, and there's going to be one on your homework today. If you see something like this, 90 degrees minus theta, like this is what you go to look at today, because that's the only thing that you're going to have subtraction on. Okay? And again, in chapter 5, once we get to that, I'm going to throw the same stuff at you, because these same ideas are going to come up. But here's what I want to do before we get into graphing. You have two questions on your homework like this today. It says, use the given function and trig identities to find the indicated trig functions. Sometimes you can just draw a picture and label it like we've done before, but the idea is if we know all these identities, we can use them to help us not have to necessarily draw a picture every time maybe. So they gave us some information. They're telling us that the secant is 5, and they're telling us that the tangent is 2 radical 6. Find the other stuff. Some of these should be really easy to do, like cosine. How does cosine relate to secant? It's the reciprocal. So if secant is 5, what do you know about cosine? It has to be 1/5, right? And if you want, you can show it here. Cosine equals 1 over secant. So if secant equals 5, that means cosine equals 1/5. Like I didn't even have to draw a picture to do that. And that's the idea with the identities maybe. Same thing with cotangent. If I know the tangent is 2 squared to 6, do I know what cotangent is? Because those are also reciprocals, so I can say cotangent is the same as 1 over tangent. And if tangent is 2 radical 6, can I just say this is 1 over 2 radical 6? Yes. And if you're going to rationalize this, remember we've had this discussion, you don't have to necessarily rationalize. I like to rationalize, so I'm going to multiply the top and the bottom by the square root of 6. And I'm going to say that's the square root of 6 over 2 times 6, or 12, right? So this answer is the same as this answer. So those we probably could have done without those identities. What about number 3? Cotangent of 90 degrees minus theta. That's one of those properties I just gave you. So what did we say the cotangent of 90 degrees minus theta will always equal? It equals the tangent of theta. If you go back here, the cotangent of 90 degrees minus theta will always equal tangent of theta. So this equals tangent. And do we know what tangent equals? 2 square root of 6. So the idea, again, is these properties, these identities, help us answer these questions. Okay, so now we have sine here. Anybody have a suggestion of how we can find sine just using our identities or what we have here? We have cosine. This is a tricky one. I think we have two options. This is what I've done in the past. I've said, well, we do have cosine, and I gave you that trig identity that said we can take sine squared plus cosine squared, and that has to equal 1. So if I know cosine, could I plug that value in and solve for that? That's one option. Something I hadn't thought of before that someone else thought of is they said, well, tangent is sine over cosine, and we know tangent and we know cosine. So could we plug what we know in and do tangent equals sine over cosine, plug in tangent, plug in cosine, solve for sine? You follow me on that? Both of those are options, but you have to pick something that has the ratios that we have and that has sine in it. And so that's why number 4 is the hard one of these, because you have to do a little bit more work. So, I don't know, this is probably easier in terms of solving than this, but I'm going to do this one first, all right? What does cosine theta equal? 1/5, but I'm squaring it, so I'm going to show that as, show my work. I'm going to say that's 1/5 squared, because it's cosine squared. And what is 1/5 squared? What is wrong with you guys today? We're all hoping for a snow day? You're disappointed that the Patriots won? It was a terrible ending. There was a fight, like it was ridiculous. It was like the worst. It was like the worst end to a Super Bowl ever. It was ridiculous. If I was going to subtract this over 1 minus 1/25, do you agree that's 24/25? Is that what sine equals? No, that's what sine squared equals. This is why my way's not, that's why whoever thought this last year, maybe Philip, I always give Philip credit for things, less work that way, but this is what I did. Because this is what sine squared equals, so I would have to take the square root of this, and I would get the square root of 24, and the square root of 25 is just 5. Am I going to leave the square root of 24 like that? That's the square root of 4 times the square root of 6, which is 2 square root of 6 over 5. Which is way easier to get that from here, just to show you really quick. Tangent was 2 square root of 6. Cosine was 1/5. Right? Was that true? So it's really kind of a little tricky with the 1/5 on the bottom, because that's really like multiplying by 5. You with me on that? Like you wouldn't multiply both sides by 5 to get rid of that, because this is really like saying 5 sine of theta, because dividing by 1/5 is the same as multiplying by 5. So you can just divide by 5 here, and look how much less work it took to get that sine equals 2 radical 6 over 5. But you do get the same thing. Worst case scenario, if you get stuck, draw a triangle, right? Label what you know, and you should still be able to solve it the other way. But I just want to kind of get you thinking about this stuff as we get into graphing. The other thing I want to get you thinking about is this idea of a periodic function. A lot of us missed that word on the test. But the idea that these functions just repeat themselves over and over again. So instead of me asking you to solve an equation just in this quadrant, I can ask you to solve an equation over a whole interval, and you can give me more than one answer. And so that's the other part of this homework today that I want to do. So I said find the value in degrees and radians from 0 to 360 0 to 2 pi. That would be all the way around my circle. Yes? We like to give answers all the way around the circle. We're going to talk about doing this without a calculator, and then ones that we would need a calculator on. If they are values from the unit circle, then they would always be on a no calculator part of the test that I would expect that you can do without a calculator. Secant, where does secant equal to? I do better with sine, cosine, tangent. So even though I could do this, where does secant equal to? I'm going to flip it over and say, what is that the same as? Secant is the reciprocal of cosine. So is that the same as saying, where does cosine equal 1/2? My brain works better with cosine and sine because it's x's and y's. So I usually change it to that. It's your prerogative. In the past, on the test that you took last week, there was more information on questions like this. It would say, where does secant equal to and tangent is negative or something, so that you could figure out what quadrant you're in. I'm not giving you a quadrant now. I'm saying everywhere around that circle, tell me where cosine equals 1/2. So if you're a unit circle person, you need to think about cosine is x. Where are all the places that x is going to be 1/2? And I believe one of them is right down here. Do you agree with that? That is 1/2 square root 3 over 2. No. Up here. That is 1/2 square root 3 over 2. Got to make sure you have the right unit circle to get the right answer. So what angle has a cosine of 1/2? 60 degrees, aka pi thirds. Give the answer in both degrees and radians. But here's the extra part, right? Every trig function repeats itself. Every trig function is positive in 2 quadrants and negative in 2 quadrants, which means if I tell you to go all the way around the circle, kind of like the bonus question that was on the no calculator part of the test, there are always going to be 2 answers here. There is another place that has an x coordinate of positive 1/2. What other quadrant is x positive in? Quadrant 4, which means I believe right down here, there is a ordered pair that is 1/2 negative square root of 3 over 2, or that would be 5 pi thirds, or 300 degrees. This would be without a calculator, so this is why I'm telling you, if you did not do well on the no calculator portion of the test, you must figure out what you did wrong and retake it, because you have to be able to do this stuff on the next test that we take. Same idea for the second one. If we want to change that to tangent, we can, but either way, it's still 1, right? My favorite one. Tangent equals 1. Tangent is y over x. So do you agree that means where on my unit circle do x and y have the same coordinates? Pi force right here, square root 2 over 2, square root 2 over 2. What other angle or what other quadrant are we going to find an angle that have x and y as the exact same ordered pair? Quadrant 3, because 2 and 4, one's positive and one's negative. But remember in quadrant 3, it's negative square root 2 over 2, negative square root 2 over 2, which means it's also going to have a cotangent and tangent of 1. So this idea of being a periodic function that repeats itself, you get the same values, which means this would be, what is that, 5 pi force? 225. All right. That's why this is really important. If they didn't tell me to only give answers between 0 and 2 pi, do you agree that I could keep giving answers forever? Does that make sense to you? Because at pi force, at 5 pi force, and if I just kept going around past 360 or past 2 pi, I'd always get back here and I'd have another answer, and another answer, and another answer, and another answer, and I would always be able to give another answer, which is why it's important to look at what bounds they give you, because you're only going to give answers between those bounds. because it just keeps going. That's what a periodic function means. It keeps repeating itself. So let's look at some that are not from the unit circle, right? On your homework today, I'll tell you which ones are with the calculator and without, but it's easy to figure out. Where does cotangent equal negative 4.3315? That's definitely not from my unit circle, so that would be a calculator question. So who needs calculator? I'm missing a lot of calculators. I'm not accusing anyone of taking them, but if you happen to have maybe took one, I appreciate that. Anyone else need a calculator? Yeah. Okay. Anyone else? I need to practice this. Okay. We've used our calculators to find like cotangent of an angle. Now this is going the other way. I want to find what angle has this value. So I picked the harder ones because if it's sine, cosine, tangent, we can just use those buttons on there. If you are solving for an angle, you are going to use the inverse buttons, which are like the ones with the -1. Right? We haven't used those yet. If you are looking for an angle, what angle has this value? Those are the buttons that you use. Again, notice there are no cotangent, cosecant, or secant values on there, so we have to think about how to plug those in, and it's different than if it's an angle. All right, so if cotangent equals this, using our reciprocal identity, you agree that's the same as saying tangent equals 1 over this? Right? Think about what we did before. When it was the angle, we put in like 1 over tangent of the angle. But now that they give us the value, you have to put the value over 1. All right? So really important that you know that. To solve for theta, just like to solve for x when it's like 2x, we divide because the dividing is the inverse of multiplying. To get rid of tangent, we do inverse tangent. So on your calculator, you are going to hit inverse tangent button, and you're going to type in 1 divided by negative 4.3315. What mode should my calculator be in? Degrees, because look at this. It tells me to give my answers between 0 and 360 degrees. So your calculator needs to be in degree mode. So that's important to know, to look at that. So in degree mode, I'm going to hit inverse tangent of 1 divided by negative 4.3315. And I get, if we're rounding, that would have to round up to negative 13 degrees. Did you get that? Negative 12.9999305. So I'm going to say that equals negative 13 degrees. Anybody need help getting negative 13 degrees? Is negative 13 degrees between 0 and 360 degrees? What could I do to make it between 0 and 360 degrees? Yeah, that's the negative angle, so they're counting backwards the way we normally do. So could we add 360 to this to make that the positive angle? Which would be 347 degrees. Okay, what quadrant is that in? Quadrant 4. Do you agree that tangent is negative in quadrant 4? That makes sense. That there's an angle down here that's 347 degrees in quadrant 4. But remember, there's always 2 answers. Your calculator will never give you both answers. Okay, your calculator gives you one, then you have to know trig to find the other one. What other quadrant is tangent negative in? In quadrant 2. So there's going to be another angle somewhere over here in quadrant 2 that has that same value. This is where, even if you love the unit circle, you have to be aware of reference triangles. You have to be aware of reference angles to do these problems, okay? Do you agree that that is going to be the same, like it should be, I drew this in terribly, the same distance away from the x-axis, that angle up there in quadrant 2, like all the ones that correspond? So there's a lot of ways you can find this, but tangent's my favorite one. This looks like just a straight line. Do you agree with that? What could I do if I'm over here at 347 degrees? What could I do to get back to that angle over there? Oliviero says, what if I subtract 180 degrees? Would that get me right over there to quadrant 2? It would. Is that the only way you could do this problem? It's not. We'll think in a minute. But you have to think about what could I do to get there. So 347 is sort of the calculator answer after you make it positive. To find my other angle, I'm going to take 347 degrees, and I'm going to subtract 180 so that I can go from quadrant 4 to quadrant 2. Why am I going to quadrant 2? Because I know that's where tangent's negative. And I get 167 degrees. You should, yes. The exception to the rule would be if the answer is like 90 degrees, right? If you were on the axis itself, you might not have two answers. But if you're not on the x or y axis, you should have two answers. And we're going to practice this more. This is day 1, but it's important to kind of think about what we're doing here. Let's do another one. This one. Here's what's also important. Each trig function is positive and negative in different quadrants. So you can't just think of one rule. Like in my Math 137 class, we've done this already, and they wanted like one rule that you should do. I should always add pi. I should always subtract pi. I should always do this. You have to look where you are and what quadrant you're trying to go to. So that's why drawing a little picture is helpful. So let's do secant. What's secant the reciprocal of? Cosine. So this is not 1 time my calculator. I'm going to write that cosine is 1 over negative 1.3054. So I can say that theta is equal to inverse cosine of that. What mode should my calculator be in on this one? How do I know? Right here. 0 to 2 pi, change your calculator to radian mode and give me a radian answer. And again, radians should be a decimal here. Let's just go to 2 decimals. I got 2.44. Did you get 2.44? 2 pi is like 2 times 3.14, so that's definitely in between 0 and 2 pi. What quadrant would that be in? Or what quadrant should it be in? Where's cosine negative? Cosine is x. Think about this is pi. So 2.14 would be less than pi. So I'm just going to draw this in. I don't really know where it would be, but this would be like the angle that I just got, 2.44. Again, every time that you do this, your calculator will give you one answer. If that answer is negative, you're probably going to have to add 360 or add 2 pi to it to make positive. But for secant and cosine, it gives you the angle in quadrant 2. And now comes the part that you have to know trig, you have to understand reference angles, you have to know which quadrants all the trig functions are positive and negative in to find the other angle. What other quadrant is cosine negative in? Cosine is x. So it has to be down here. Yes, there has to be another answer down there. And I'm just going to draw the picture. Again, I don't really know where 2.44 is, but what matters is that you know that it's somewhere in quadrant 3. Here's where I think reference angles are super important. Do you agree? If these are the same value, they have to be the same distance from the x-axis. So whatever this is, this will be the same distance. That's the idea of a reference angle. If you look at all the pi 6, they're the same distance away, the pi 3rds, the pi 4ths. Could we figure out what this reference angle is? Because we know this whole thing adds up to pi. So could I just take pi minus 2.44 to get that right there? My calculator, pi minus 2.44. That's like 0.70 if I round to 2 decimal places. That means that this is also 0.70 away. Reference angles, if they have the same trig values, they're the same distance away from the x-axis. They have the same reference angles. So to find what this new angle is, can I figure out what angle goes from here all the way to here now? Can I just add those all up? Or you could even say pi plus that. I don't know. I got 3.84. Did you get 3.84? Sometimes people see, this is how I always do it in my Math 137 class. They told me that they saw it as 2.44. This was the same distance, only going the other way. So they took 2 pi minus 2.44, and guess what? You get the same answer. I don't visually see it that way, but it works. You get the same answer. So the idea is you just want to be aware that, like, you could take 2 pi minus 2.44, and I think you get the same answer. That's why I was just checking up here when I did that. Again, it's one of those things that my brain doesn't see it that way, but that doesn't mean it's the wrong way to do it. You just get the same answer. So this kind of stuff we're going to talk about all throughout this chapter as we start solving stuff, but I like to start with this before we get into the graphs. You got to know how to do it without a calculator for the unit circle stuff. You got to know how to do it with the calculator and find that second answer, because if you don't find the second answer, that's a big deal. I have one more on here. All right. I'm going to be quiet a minute and let you do this, and I'm going to walk around because for some reason no one's talking at all today. And see where you are on this. Cosecant is sine, the reciprocal of sine. I think we should still be in radian mode. See if you can get the one answer from your calculator. I think it'll be negative. You don't have to add to get a positive. And then try to think about what quadrant you should be in, or at least where we should go from there. And then we'll do it, and then I'll give you some homework. Oh no, it's not negative. You're right. Sorry, it's positive. It should be positive. Just kidding. So your calculator should give you one answer, and then you got to think about where would the other answer be. How would I get it? Just like when we took the calculator portion of the other test for chapter 4, really important that you pay attention to what mode you're in, because that really can change answers here. But I saw lots of answers like this. One answer, 1.13 if we round in 2 decimal places. That's sine and cosecant, which is positive in quadrant 1. That's an answer in quadrant 1. So that means somewhere in quadrant 1, doesn't really matter how accurate this is, as long as you just draw this in here. I'm just going to say that's 1.13. Now you have to think, what other quadrant is sine, aka y, positive? So somewhere over here, there's going to be another angle with the same trig value. We have to figure out what that angle is. Again, the way I see it, and then maybe the way you see it. But for me, I think about the reference angle. Is this reference angle going to be the same as this angle right here? 1.13. So what I need to know is what is the angle that goes from here to here? How could I figure that out? Yeah, if this whole thing is pi, could I take pi minus 1.13? And I get like 2.01. Okay. Questions about that? I have a worksheet for you today, but this worksheet you need to keep track of because it's like on your homework sheet, right? Like it's for your homework, but it's a worksheet. I know that's asking a lot at the very beginning of the chapter. I want to talk about this real quick before you get working on it. No, it's like a real worksheet. Once you all get it, I want to talk about which problems you should be doing without a calculator. Because like on 1 through 6, I just said give exact answers when possible. That means if you could do it with the unit circle, I mean to do it without a calculator. So just looking through there, number 3 and 4 and 5, those you should be able to do without a calculator. Okay? And then look at 7 and 8, and there are 2 on the back, 9 and 10. Just want to point out that 7, 8, 9, and 10 are not multiple choice questions. Is everybody clear on that? 7, 8, 9, and 10 are like our first question, that there are 4 parts to each one. So what you should not do on 7, 8, 9, and 10 is just circle A, B, C, or D, which is what happens every year, even though I say this. They're not multiple choice questions. Everybody clear on that? They thought they were going to start delayed. We can maybe, well, okay. Actually, wait, so you get to number 2. Try number 2 if you haven't, if you haven't started number 1 yet. We can talk about it before you get there. Freak out. Number 2, you should hit inverse cosine, negative 1.7. Has anybody done that in their calculator yet? What does it say? I could give you this one, and then every year people come in and they stop after number 2 because they got stuck on it, and then they didn't even try the rest of it. But mine says domain error. Does yours say domain error? And so you think I must have done something wrong. I thought I was doing it right, but I've done something wrong. So think about what this is saying. This is saying what angle has a cosine of negative 1.7? And I know it's been a while since we talked about this. When we talked about domain and range of sine and cosine, we talked about the fact that they're periodic. What did we say the smallest value that cosine can ever be is? Yeah, if you think about your unit circle, right, we get negative 1 over here for cosine, we get 1 over here, we get 0 and 0 here if we're just thinking about x coordinates. And we talked about that the biggest, we have that unit circle worksheet, you fill out this stuff to the bottom, the biggest value that you'll ever get is 1 for cosine or sine. The smallest value that you'll ever get is negative 1, and they just rotate around those values. So the reason that your calculator says that there is a domain error on number 2 is because there is no angle that will ever equal negative 1.7. It doesn't exist. So you can put undefined, you can put no angle, I don't know, I would put undefined. That's the only one like that on your worksheet. But I just want to remind you that not all values have a sine or cosine that go with it, all right? So that one's undefined, so I just did one of your problems for you. The rest of them, you should be able to do either with the calculator or without. If you're not sure about this, start, like number 1 is with the calculator, start it, and if you need help or you want me to check it when you're done, I would be happy to do so. I also have assignment sheets for you. I'm going to go ahead and pass out.